Hello everyone, welcome to my channel, and as you all know we are doing a problem session, and in this series we have done 4 problems in our previous videos, and now it is turn of the problem number 5, and let us try to see the problem and then we'll discuss about it. This particular problem, problem number 5, I have based it on carbanion. What is carbanion? A carbon, a species having carbon bearing negative charge. So in the problem you can see there are 4 carbanions A, B, C and D. You have to see these carbanions carefully. You have to see what features are present which can give stability to these carbanions. And after assessing all those merits, the features, we have to decide which is most stable and put a hierarchy in decreasing order. So I will start with A and then we'll move so on. We'll assess each carbanions and then we'll decide. Okay. So let us first start with A. As you all can see, this A has a carbon, as you can see this carbon which is bearing the negative charge, so it's a carbanion, and this particular carbon is directly attached with 3 carbons as you can see. So I have already told you, if a carbon is attached with 1 carbon, it is primary. If it is attached with 2 carbon, it is secondary. If it is attached with 3 carbon, it is tertiary. So the present carbanion structure is a tertiary carbanion structure. Now as you all know, a negative charge it may be or a positive charge it may be, it's like a burden. The presence of charge is a problem, a burden. And what I have told you, if you share this burden, if you disperse this burden, these charges amongst the atoms, then if you share the burden, the stability increases. So in that sense, first you have to see whether there is any way we can share the burden, we can transfer the minus charge from one atom to another, and one of the prominent way we have already seen in the form of resonance, the mesomeric effect. So let us try to see if at all it is present or not. So if you see this minus charge, then you realize minus, single, double. The moment you see this conjugation, you are confirmed that there is a possibility of resonance, delocalization of charge. On that basis, now I am going to do the resonance and will make another resonating structure. For that, what we have to do, these 2 electrons, this negative charge, this is going to now flow and it will spread in between the carbons to make a pi bond. And this pi bond simultaneously is going to shift on this particular carbon. So as you know, the electrons are moving away from this carbon, so it will acquire a plus charge. It already had a minus charge, so plus and minus becomes 0, so it acquires a 0 formal charge. And these lone pair, now it spreads between the 2 carbon to make a new pi bond, and simultaneously this pi bond which involved 2 electrons now will sit on this carbon as a lone pair. So you can see a new lone pair, and to which the electron goes towards, it acquires a negative charge, so you can see a negative charge. So from these fundamentals you have created the 2 resonating structures. Now after looking at these 2 resonating structures, let us try. I have already told you that this is a 3-degree carbanion structure. What about the structure 2? You understand the carbon now which is bearing the negative charge is directly attached with 2 carbons, just 2 carbons as you can see. Therefore, it is a 2-degree carbanion structure. So the 2 resonating structures you have obtained, the left one is the tertiary and the right one is secondary, and there is a possibility of resonance. What resonance has done? It has spread the negative charge. It has done the delocalization of charge. It has done the delocalization, the sharing of burden, crisis, and because of which the stability increases. Now, what is the result of these 2 resonating structure is a resonance hybrid. Actually what is happening, basically this carbanion is not going to be represented completely by either structure 1 or structure 2. To represent it completely, we have to create a hybrid. Hybrid means you have to take contribution from both the structures, structure 1 and structure 2. And you have to take the contribution, you have to mix the contribution and make a new species which is called as hybrid, and it represents the actual molecule nearest. Okay, so the hybrid, as you can see, I have made the dotted line. You can understand what is the meaning of dotted line. The meaning of dotted line means the pi bond character is present. Okay, so you understand the pi bond character between these 2 carbons are coming from this pi bond. Similarly, I have put the dotted marks here also. So here in between these 2 carbon, the pi bond character is coming from the structure number 2. So once you take the contribution from 1, this pi bond character comes. As you take contribution from structure 2, this pi bond character comes. And you understand the minus charge is now not localized, it is delocalized. And you can see earlier it was on this carbon, now it is on this carbon. So there is a delocalization of negative charge, and therefore I have not localized the negative charge just on a single carbon, but I have denoted it delocalized between these carbons. Okay, so this is how we are going to make the hybrid, and the delocalization of charge is happening and it gives the stability to the carbanion A. Now let us come to the structure B, the carbanion B, and try to find what is possible. Once we see this carbanion, again we see a carbon which is bearing a minus charge, and it is directly attached with 3 carbon, as you can understand, like this. So it is a 3-degree carbanion. Okay, this structure is a 3-degree carbanion structure. Now coming on to the possibility of delocalization, what we call as resonance, let us try to find if there is a possibility of conjugation. If you see this negative charge, so you understand negative charge, single bond, double bond. So there is a possibility of resonance, there is a straight away conjugation. So what you should do, you should spread the lone pair 1 position ahead towards the pi bond like this, and simultaneously you should take these pi electron and put it over this carbon, and if these 2 electron floats, it develops a pi bond, it goes away from this carbon, this acquires a plus charge, and plus and minus becomes 0 formal charge. Simultaneously this pi bond sits on this carbon, and the 2 electron, now earlier they were making a pi bond, now there will not be a pi bond, they will just sit as a lone pair, and since electron is coming towards this carbon, so it will have a negative charge. So you have created these 2 structures, and after you have created these 2 structures, what next you can do? The next thing you can do is, what is the next possibility? Now you understand, again there is a possibility of further resonance. How? this minus, single, double. So you can advance these lone pair in forward direction in this manner, and they will make a new pi bond, and simultaneously this pi bond is going to sit over this carbon and will look as a lone pair in the next structure. And as you can see, as these lone pairs have floated, it makes a new pi bond, and as these pi bond sits over this carbon, it looks like a lone pair, and obviously the negative charge comes to a place where electrons shift towards. So a minus charge comes. After you have seen that this is a species which is resonance stabilized, as you can see, not just two structures, we have got now three structures. Earlier we got just two resonating structures, so there was a limited delocalization. Now more delocalization we have seen. We have got three structures, and minus charge is delocalized to a larger extent. You should understand, I have already told you minus charge is a burden. If you have a crisis, if you have a problem, a burden, and if you have more number of friends with whom you can share your feelings, your burden, your crisis, you will be more happier. So that is what is happening. More the number of resonating structures, more number of structures are now there to help in spreading of the burden, the negative charge. So it is a good symptom that it is spreading the negative charge more, and this is the hybrid I have drawn. As I have already told you, none of the three structures which I have drawn can represent the carbene ion completely. In order to represent the carbene ion completely, you should take contributions from each resonating structure. Okay, so once you take the contributions from each of the resonating structures, you come to know that there is a pi bond character which is present in between these two carbon. As you can see, this is the pi bond character which has come. So a dotted mark which you see in the hybrid, it represents the pi bond character. And again you see the pi bond character here, so the dotted marks are here also. Again you see the pi bond character in between these two carbon, so dotted marks here also. Again you see the pi bond between these two also, so dotted bond here also. So these are the pi bond character which you will obtain in the hybrid. Okay. The next important thing is the minus charge is now delocalized from this carbon to this carbon, and it stays at this carbon, it stays at this carbon, and it stays at this carbon. So you understand, the minus charge is delocalized, it is delocalized in the ring also. So I have made that a partial negative character will be borne by the ring, and partially it will be borne by this carbon. Okay, so this is how you should draw the hybrid. So what is the meaning of partial negative? The meaning of partial negative is, students, that the complete negative is now became a partial negative. Whenever there was a complete minus, that means the burden is localized on you. As there is delocalization, the burden reduces, and you use the symbol partial. Partial means now it has declined, the value has dropped. That is the meaning, and that is the function of resonance. It decreases the burden on one carbon. It spreads the charge, and as it spreads, the stability increases. More it spreads, more will be the stability. So on that ground you have to understand. Now coming on to a structure, the carbene ion C. If you see the possibility in C, you find that, okay, this is a carbon which is bearing the minus charge, and it is directly attached to 2 carbon. As you can understand, it means it's a 2-degree carbene ion. Okay, now next you have to see whether there is a possibility that the minus charge can be spread can be delocalized and therefore the burden is reduced. Okay, let us try to find the conjugation. The moment I see minus, single, double, I am happy that there is a possibility of resonance, there is a conjugation. And in order to avail that conjugation, let us try to avail it. You have to spread this lone pair in between these two carbons, and simultaneously you have to shift this pi bond on this carbon. As these two electrons spreads, it makes a new pi bond, as you can see. And as these two electrons which earlier were making a pi bond, now they sit on this particular carbon as a lone pair, and the electrons are coming towards this carbon, therefore it is acquiring a minus charge. That is how you have drawn the structure number 2. If you assess the structure number 3 based on whether it is 1 degree, 2 degree or 3 degree, you immediately find that it is having a carbon which is directly attached with 3 carbon, as you can understand. So this particular structure is a 3 degree carbene ion. After you have done this, now let us try to see whether the next double bond, because in this carbene ion, you see not just a single double bond is present, there are 2 double bonds. So we have already taken into consideration this pi bond. Now we have to take into consideration this pi bond, whether it is in conjugation with the negative charge or not. Now, why I am saying with the negative charge, you should understand. Your whole concern was how the negative charge should be dispersed. It should be distributed among different atoms so that the burden is reduced. For that to happen, this minus charge must be in conjugation. So the top pi bond, you found that the minus charge was in conjugation, you did the delocalization, and we have made the structure number 2. Now coming on to this pi bond which is in the bottom of the molecule, you have to think whether it is in conjugation with the negative charge or not. Let us try to see whether it is in conjugation or not. Let us try to sing the song. Minus, single, single. From left side. Now let us try from the right side. Minus, single, single. Then double comes. Now this is not the song which is meant for conjugation. You should understand, it should go like this. Minus, single, double. It should not happen minus, single, single. No. There has to be alternate single and double. So on that condition, on the basis of that important condition, you immediately realize that this pi bond is not in conjugation. This is not in conjugation. With what? With our concern, the minus charge. So the minus charge is going to be taken care by resonance just by one pi bond and not by this pi bond. So what what next this pi bond can do, we will come to elaborate on this in the latter situation. So we have drawn the 2 structures, and now as you all know, we can draw the hybrid also. To draw the hybrid, the thing is we have to take the contribution from the structure 1, we have to take the contribution from structure 2, and you understand now the minus charge is delocalized from this carbon to this carbon, you should understand. So a limited delocalization happening, and from this delocalization the pi bond character is developing here also and here also. You should understand, because we were discussing about the conjugation, we were discussing about the stability of carbene ion. I took into consideration the conjugation with the minus charge. I did not take the double bond conjugation. What I mean to say is, if you see there is another possibility of resonance which will not take the minus charge into consideration and therefore is meaningless in our question. What I am talking about is this. If you see double, single, double. So if you try to see this, there is a resonance. but that resonance is not going to affect this minus charge or is not going to delocalize this minus charge. And since our concern was to see the stability of carbene ion, which depends on whether the negative charge remains localized or delocalized. If it is delocalized, the stability increases. So from this conjugation double, single, double, it has nothing to do with the delocalization of the minus charge. So we are not taking that into consideration from the point of view of our question. Is it okay? So please keep that in your mind. So minus charge is conjugated in a limited manner. Now let us come to the the last one, the D1. If you see the D1, it is showing you some prominent feature, and what that prominent feature is, let us try to diagnose that. First of all, once you see that this is a carbon which is bearing the negative charge and it is directly attached with the 3 carbon, so you immediately realize that it's a 3-degree carbene ion. This is the first thing. Now the second thing you can observe is this negative charge is in conjugation with the double bonds. And how it is in conjugation, let us try to see. Minus, single, double, single, double. Once you have done this, student, you have incorporated this carbon, this carbon, this carbon, this carbon and this carbon. How? Let us see it once more. Minus, single, double, single, double. So there is a cycle. There is a cyclic conjugation. Why I am saying cyclic conjugation? Because in this song of conjugation, you have taken all the atoms, all the 5 atoms of the ring into consideration. And let us try to count the number of electrons which are involved in this cyclic conjugation. So 2 electrons from here, 2 electrons from here and 2 electrons from here. So if you count 2 plus 2 plus 2, it gives you the figure of 6 pi electrons. And this is what we are emphasizing on. It follows the Huckel's rule, 4n plus 2 pi figure. If it is followed, it is aromatic in nature. And if you put n is equal to 1, this figure of 6 comes. So the structure 1, immediately you realize that it is cyclic, it is flat in nature, it involves the cyclic conjugation and the number of electrons are 6. So it's an aromatic carbene ion, and you understand aromaticity is a class ahead. It gives you extra stability, and because of that, first of all, you understand it is aromatic, and aromatic comes a class ahead. It's a top class, so it stabilizes it the most amongst the given options. And second of all, if you simply compare with the resonating structures also, you come to a conclusion that the 3 we have discussed, the maximum number of resonating structures we obtained were 3. And this particular aromatic carbene ion, if you try to understand, it is having 5 resonating structures. From the figure itself, you can see this is minus charge, minus single double. You can simply delook. Let me clear the screen first. Okay, 1 second. You can see from here only this minus charge comes like this, and these pi electron goes like this. So a pi bond comes here and the minus charge sits here. So second structure. Then this minus charge goes, these 2 electron, the lone pair goes like this, it sits over here. So you get the structure 3. A pi bond come here and a lone pair now sits here. Then minus single double. So it delocalizes like this, and these pi electron sits on this carbon. And finally, this minus single double, you put it like this and you do like this, and this carbon is going to get a lone pair like this. So from this practice also you have seen it is having maximum number of resonating structures. So the minus charge is not dispersed throughout the ring. All the 5 carbons are going to help you in sharing the burden of minus charge. So this is the best help you have got till now. Most number of resonating structures. So that is how you have to perceive the things, and above all, it's aromatic in nature. Why it's aromatic? I have already told you. It's a cyclic, it's a flat, there is a cyclic conjugation, and 6 pi electrons are involved in the cyclic conjugation. On that ground, we have finally diagnosed it. So if I try to put the things together and now start a comparison. Now I have written all the A, B, C, D in an order. Means I have written the merits in front of all the A, B, C and D. And then we will compare the merits. Okay. So let us come to a comparison. Once we start comparing, we find that the A carbene ion had 2 resonating structures. One was 2 degree, another was 3 degree. So there was delocalization present. Okay. Okay. Now if we see the B carbene ion, it had 3 resonating structures. And you know, more the number of resonating structures, higher will be the stability. Okay. So please keep that thing in your mind. Once we see the C carbene ion, we found 2 resonating structures, 2 degree and 3 degree. Once you say 2 resonating structures, then on that ground, there is a compromise, there is a tie between A and C. Because A also had 2 resonating structures and C also had 2 resonating structures. So what else is giving an edge to any of A or C is the minus I effect now. Now, why I am saying this, let us try to understand. If you see the C structure, so once again I am going to make a picture of C and will make you understand. So if I draw the C carbene ion, so let us draw the C carbene ion, and now we'll see what is the extra thing you are having in the C. So this was C. Okay. Now once you start comparing, you understand this minus charge is in conjugation with this double bond, minus single double. Okay, that is there. Now if you see these 2 carbons, these 2 carbons are sp2 hybridized. You understand? sp2. Why? Because you understand one hydrogen will, because carbon makes 4 bonds. 3 you see on in the diagram. Okay, the 4th is going to be satisfied by hydrogen. So you understand there is 1 sigma, 2 sigma, 3 sigma. Similarly here also 1 sigma, 2 sigma, 3 sigma. No lone pair. So number of sigma bonds 3, lone pair 0. In order to find hybridization, I have already told you. You have to find the steric number. Steric number is what? Number of sigma bond plus number of lone pair. And as you understand, it had 3 sigma and 0 lone pair, it comes out to be 3. If it is 4, then sp3. If it is 3, then this is sp2. If it was 2, then it would have been sp. So it is sp2. It has 2 sp2 hybridized carbon, and you should understand the sp2 hybridized carbon are minus I in nature. What is the meaning of minus I? The meaning of minus I is they withdraw electrons from the sigma bonds. You understand? The 2 sp2 hybridized carbon are linked through sigma bond to the negative charge. So what these sp2 hybridized carbon do, they pull the sigma electrons, and as they pull the electrons, it helps in spreading the excess of the minus charge on this particular carbon. So this had the, you can say, a flood of electron. So if you have minus I groups like the 2 sp2 carbon, so it pulls the water from the flood situation, and if you pull away the water from the flood situation, there is a relief in the flood. Okay, on that ground, these 2 sp2 hybridized carbon are pulling the electrons away from the site of negative charge and helps in spreading the minus charge. but you understand the resonance effect is a prominent effect. Resonance also tries to pull the minus charge, spreads the minus charge. Minus I is also spreading the minus charge. But which is a prominent effect? The stronger effect. Resonance is a stronger effect than the minus I. And that is why, if we come back to the original situation, the three resonating structures amongst A, B, C was the most stable carbene ion, because it had most number of resonating structures amongst A, B and C. I am not comparing it with D right now. Amongst the C and A, if you try to compare, this extra advantage of minus I effect, because of these two sp2 hybridized carbon, it is it is having more stability than the carbene ion A. So that is a merit of the carbene ion C. And once we talk about D, I have already discussed you in a significant manner that it is a way ahead, because it has aromatic character. Not just aromatic, although aromaticity was the most important feature, it had 5 resonating structures, and none of the A, B and C had this much of resonance delocalization. So after reading all the basic differences and comparing those, you have come to a conclusion that the most stable is going to be D. After D, it is going to be B, most number of resonating structures among A, B and C. After B will come the chance of C, and the least stable is going to be A. So this is going to be the final answer. So I hope you may have understood all the fundamentals, and I have tried all to break it into small bits so that you can understand those small things. Okay, so like these the 5 problems, we will come up with more problems, and this is what I have decided, that I will make several problems based on these fundamentals, which students find it difficult to decipher, how to know which is a more prominent effect, which is a stabler intermediate, like that. Okay, so till then, take a good care of yourself and keep watching my videos. Thank you very much.